After 6 years of continuous development, NASA and the US defense company Lockheed Martin have finally unveiled their groundbreaking quiet supersonic aircraft, the X-59 Quest. What revolutionary technology does it bring? And when can we expect to experience supersonic passenger flight? Stay tuned until the end to find out. It's sooner than you might think. The Sonic has long been the Achilles heel of supersonic flight. When an aircraft travels faster than the speed of sound, the compressed air molecules around the plane create shock waves that merge into a sonic boom, a loud and disruptive noise heard on the ground. This noise has historically been a significant barrier to the commercial viability of supersonic flight over land. Many of the issues with supersonic flight trace back to the Concorde, the famous supersonic passenger jet that could travel from New York to London in just 3.5 hours. When the Concorde first took flight in 1969, the idea of superfast air travel thrilled people until they heard the actual sound. As the plane zoomed overhead and broke the sound barrier, it sent a deafening boom to the ground below, shattering glass windows and rattling doors. The Concorde's delta wing design, with its two large triangular wings and powerful engines, contributed to the sonic boom. As planes began to go supersonic over the continental US, the resulting sound explosions became so problematic that Congress banned civilian supersonic flights over land in 1971, a move later adopted globally and officially enforced in 1973. Public opinion surveys heavily influenced the ban. In cities where supersonic military jets flew overhead, with many people expressing dissatisfaction with the noise and the way it rattled their windows. This ban stalled the development of the transportation industry for many years. However, in 2016, NASA asked Lockheed Martin and other companies to submit proposals for a test airplane to demonstrate that supersonic flight over land could be safe and as quiet as regular subsonic airliners. The goal was to create a plane with a sonic boom of just 75 perceived loudness, decibels pulled, a unit that measures how people perceive sound, rather than the actual decibels produced by the sonic boom. A 75 pulse is comparable to hearing a dishwasher for less than a second. By comparison, the Concorde's pulse was 105, as loud as listening to a chainsaw at full power. In 2018, NASA awarded Lockheed Martin a $247.5 million contract to build and deliver the low-boom X-plane. The aircraft, officially named the X-59 in a Quest program quiet supersonic technology, received its moniker from the US Air Force in June 2018. But Lockheed Martin still faced a long road to developing a truly quiet supersonic jet.
By November 2018, Lockheed Martin had begun machining the first part of the X-59 in Palmdale, California, with major structural components assembled by May 2019. Fast forward to November 2022, when the General Electric F414G100 engine, which powers the US Navy's F-18 Super Hornet, was installed in the X-59. The engine is positioned on top of the plane rather than underneath, maintaining a smooth, loud profile that prevents shock waves from reaching the ground. Since then, the aircraft has undergone various tests, from weight checks and fuel system evaluations to ground vibration assessments. Remarkably, the X-59 came in below the anticipated weight, a rare achievement in aircraft development that surprised the entire unveiling team. The X-59 was previously rolled out for cameras in August 2023, but that was before it received its final red, white, and blue paint job. Finally, on Friday, January 12, NASA and Lockheed Martin officially debuted the agency's X-59 quiet supersonic aircraft. This is a major accomplishment made possible only through the hard work and ingenuity of NASA and the entire X-59 team, said NASA Deputy Administrator Pam Melroy. In just a few short years, we've gone from an ambitious concept to reality. NASA's X-59 will help change the way we travel, bringing us closer together in much less time. Following the unveiling, Lockheed Martin highlighted the aircraft's meticulous design. The X-59, measuring 99.7 feet long and 29.5 feet wide, is designed to reach a speed of Mach 1, 2024, equivalent to 925 miles per hour, at an altitude of 55,000 feet. This supersonic marvel opens doors to various applications, including rapid medical response, shorter shipping times, and, of course, faster travel. When the curtain finally fell to reveal the X-59, the assembled crowd applauded and eagerly captured photos of the new jet, shining in its red and blue under the stage lights. During the rollout, the X-59's striking and unique geometry was fully displayed, featuring a sharp, elongated beak-like nose section that measures 38 feet in length. The nose section helps shape the shock waves the aircraft produces during flight. NASA has stated that this nose design means pilots flying the X-59 cannot see out of the jet's forward windscreen because it doesn't have one. Instead, pilots use NASA's External Vision System 15s to see ahead. This system uses a forward-facing camera, a cockpit-mounted display screen, and custom image processing software to create an augmented reality view of the X-59 pilot's forward line of sight, complete with graphical flight data overlays. As exciting as this unveiling is, it's only the beginning of the X-59. Rollout is a major accomplishment, but it also means the next milestone is first flight and then supersonic flights after that, said Catherine Baum, manager of NASA's Low Boom Flight Demonstrator Project and development led on the X-59. Our eyes are on the mission. With the rollout complete, the Quest team will now focus on the next steps, including integrated systems testing, engine runs, and taxi testing in preparation for the X-59's first flight. Although the first flight was anticipated for last year in October, NASA officials delayed the inaugural flight to 2024 due to several technical challenges identified during 2023, including intermittent issues with some safety redundant computers. The Quest team will conduct several flight tests at Skunk Works before transferring the aircraft to NASA's Armstrong Flight Research Center in Edwards, California, which will serve as its base of operations. Once the X-59 has flown over half a dozen residential communities across the US chosen to offer a diverse mix of geographic and atmospheric conditions, NASA will engage with the communities on the ground to gauge their response to the noise. The goal is to confirm the theory that a 75 PLDB boom will be acceptable. The data gathered will be presented to the US Federal Aviation Administration (FAA) and international regulators. NASA believes that a change in regulations could open the skies for a new generation of supersonic aircraft allowed to fly over routes that are currently off limits, such as New York to Los Angeles, potentially advancing flight time in half. While the X-59 is not a prototype but a technology demonstrator, several companies are already developing supersonic passenger aircraft, including Hermes, Boom, and Spike, with plans to fly them within a decade or less. However, it's uncertain whether these companies will be able to leverage the findings from the Quest program, which will likely inform the next generation of supersonic aircraft. Such aircraft, capable of flying anywhere, would democratize supersonic travel, marking a stark contrast to the Concorde's luxury status. The future looks bright for supersonic flight. Who knows, maybe in a few years, we'll be able to travel twice as fast as we do now. But for today, that's all we have for you. If you enjoyed this video, don't forget to like it, subscribe to the channel, and turn on notifications to stay in the loop. Thanks for watching.